Hi, welcome to my video on find the value of cos and sine between 0 and 360. We start off with the unit circle. This is a circle indicating a circle with a dot in the middle. The radius of the unit circle is 1, and so I'll draw a circle around the x and y axes. And the radius is 1, so from here, which is 0, 0 out to here, this point is 1, 0. X is 1, y is 0. This point right here, x is 0, y is 1. This point right here, x is negative 1, y is 0. And this point down here, x is 0, y is negative 1. So this is the unit circle whose radius is 1. And let's do the graph of x equals sine theta. X equals cos theta. Cos theta is in terms of x. And we're going to go from 0 less than or equal to theta to less than or equal to 360. So we're going to go all the way around the circle in the positive direction. So cos is the x. So at 0 degrees, which is right here, the x is 1, and at 90 the x is 0, and at 180 the x is negative 1, and at 270 the x is 0, and all the way around 360 we're back to 1 again. 360 and a 1. So notice the graph is looping like this. And notice that the cos graph is a sideways C. Sideways C. And notice it starts at 1 and ends at 1, and it makes a sideways C. Let's look at the equation cos theta equals a half. So this equation came from x equals cos theta and x equals 1/2. So when you combine these two by transitive property, because they're both equal to x, you get this equation. So let's look at this is the graph of x equals cos theta. Let's look at the graph of x equals a half. So x is a half right here. So this is a horizontal line. All values of x are a half. So all values of x are a half is right through here. And it's kind of different because if you think of it, most graphs are drawn, this is theta and this is the y. But remember, on the circle, the x is the cos and the sine is the y. So this is hard to get your head around, but just got to be careful. So this is x equals a half. The x values are a half all the way along. Notice that there's 2 points where the cos graph and x equals a half intersect. And that's just before the 90, which is in quadrant 1, and it's just after 270, which is in quadrant 4. And also, what about the graph of the equation, of cos theta equals negative a half? So that's x equals cos theta, and the equation x equals negative a half. So x equals negative a half is down here. So that's x equals negative a half all the way along there. And notice that the cos graph and the x equals negative a half intersect here between 90 and 180, and they intersect here between 180 and 270. So x is negative between 90 and 180, and between 180 and 270. X is positive before 90 in the first quadrant and in the fourth quadrant after 270. So I'll illustrate that as you can see on this circle. So x is a half. If you take x, this is x is a half here, and right here. There's x a half right in the middle. So that point is right there and right there, which is in the first quadrant and the fourth quadrant. X is a negative a half, is halfway between -1 and 0, which is here. So x is a half in the second quadrant and in the negative a half in the second quadrant and the third quadrant. So x is positive on the right, negative on the left. Note, the radius is 1. So on a unit circle, the values of cos theta are -1, less than or equal to. And we could put cos theta here, or we can also put the x, less than or equal to 1. So the values of cos theta go between -1 and 1, including -1 and 1. Okay, that's looking at the cos graph, where there's, if you have a half or negative root 2 over 2 or positive root 3 over 2, then you're going to get two values. And again, looking at the same, I wanted to draw two different diagrams instead of putting it all on one. So a unit circle got a radius of 1. This point right here is 1, 0. This point right here is 0, 1. This point right here is -1, 0. And this point here is 0, -1. Extremely important to know about the unit circle. And the sine graph is related to the y, so we're going to look at from 0 to 360. So y, theta, and value of y. So at 0 degrees, the y is 0. At 90 degrees, the y is 1. At 180, y is 0. And at 270, the y is -1. And back to 360, y is 0. So this is the sine graph. There it is. And just to mention again, the sine graph is a sideways S. Notice it's sideways S, going sideways. Notice that the sine graph starts at 0, goes up to 1, back to 0, down to -1, and back to 0. So the sine graph is a sideways S. Let's look at the equation. Sine theta is a half. And this equation came from y equals sine theta and y equals 1/2. So this is the graph of sine theta. So the y equals 1/2 is this line moving through here. So this is y equals 1/2, and it intersects right here and here. Notice that the y equals 1/2 intersects in the first quadrant between 0 and 90, and in the second quadrant between 90 and 180. And let's look at the other equation. Y equals sine theta and y equals -1/2. Again, if you put the two of these equations together, you can see that by transitive property, sine theta is -1/2. -1/2 is right here for y, and hence the intersection of the sine graph and y equals -1/2 are these 2 points. And these two values of theta are between 180 and 270, and between 270 and 360. So that looks like in the 180 to 270 is in the third quadrant, 270 to 360 is in the fourth quadrant. That's where sine is negative. Sine is positive in the first quadrant and the second. And just look, if you take y as a half, y is a half, y is a half right here. So there's y is a half right straight through there. So it hits here, which is in the first quadrant between 0 and 90, and it hits here, which is in the second quadrant between 90 and 180. And negative, y is -1/2 is right straight through here. So it hits the circle in the third quadrant between 180 and 270, and in the fourth quadrant between 270 and 360. And again, note the radius is 1. On a unit circle, the values of sine are -1 less than or equal to sine, or we could say y less than or equal to 1. So the values of cos and sine on a unit circle go from -1 up to 1. That's the range. You think about it. And so let's solve some equations knowing that. So find the value of theta from 0 less than or equal to theta less than 360. And the steps is I'm going to find the quadrants. I'm going to draw the terminal arm, draw the right triangle to the x-axis, find the reference angle, and then find the values of theta. Here we go. So we're going to find the quadrants. We're going to find the quadrants using the cash rule or add sugar to coffee. I prefer to use add sugar to coffee because A, S, T, C, A stands for all, sine, tan, and cos. The reason I like ASTC, add sugar to coffee, because you start all, it's A, first letter of the alphabet, you start with first quadrant. But if you use the cash rule starts in the fourth quadrant. Just be careful. So we have sine is equal to root 2 over 2. Sine is positive, so sine is positive in 1 and 2. So we'll draw the diagram in 1, and we'll also draw the diagram in 2. I'm separating them now so you can see, so there'll be no confusion. So we found the quadrants of 1 and 2, so we'll draw the terminal arm in quadrant 1, and we'll draw the terminal arm in quadrant 2. So we drop a right triangle to the x-axis. We drop a right triangle to the x-axis. So sine is the y. So the y is root 2 over 2. The y is root 2 over 2. That means that this x is a half. Hypotenuse is 1. Oh, this x is root 2 over 2. Sorry about that. This x is a negative root 2 over 2. Because we have root 2 over 2, then both angles are going to be the same. So the reference angle is 45 and 45. So this is the first quadrant reference angle. So theta is equal to the reference angle, which is 45 degrees. And in the second quadrant, remember theta is the rotation from here right to here. That's theta. And theta here is from the initial, from 1, 0 over to here. So that's theta. So in this quadrant, theta is 180 minus the reference angle. So that's 180 minus the 45 degrees, and that's 135 degrees. So that's the two answers for this question. And again, if you take your calculator, root 2 over 2 is 0.707. So if you hit sine of 45, you get 0.707. If you hit the sine of 135 on a calculator, you get 0.707. Remember, decimal 707 is equivalent to root 2 over 2. So let's try another one as an example. Again, let's look where we're going to find where the cos is positive. So add sugar to coffee. Cos is positive, first quadrant for sure, because they're all positive, and cos is positive in 4. So let's draw a couple of circles. 1. So we have to draw it in the first quadrant, terminal arm, and in the fourth quadrant, terminal arm. So the rotation for theta is this far, and the rotation here is all the way around till we get to here. Drop a perpendicular to the x-axis, perpendicular to the x-axis, and now we have cos is root 3 over 2. Cos is the x, so the x is root 3 over 2, and the x is root 3 over 2 in each quadrant. That means this is 1, because it's a unit circle. That means this side here is a half, and this side here is a negative a half. But opposite the half is a 30-degree angle. Opposite root 3 over 2 is a 60-degree angle. So the reference angle for both of these is 30 degrees. And so here's a half, so that's 30, and that's 60. So the reference angle is 30 for both of these. So we're in the first quadrant. So theta is equal to the reference angle, which is equal to 30 degrees. And theta here is right around, so theta is 360 minus the reference angle. So that's 360 degrees minus the 30. So that gives me 330 degrees. So check. Remember, root 3 over 2 is 0.866 as a decimal. So the cos of 30, it gives you 0.866. You know you have the right answer for 30. And the cos of 330 should be 866, 0.866. Okay. Now we have some more to do. These are for you if you wish to pause. And here we go. Pause the video. Find the value of theta, 0 less than equal to theta less than 360. So we have to find where they are positive and negative. So add sugar to coffee, or use the CAST rule, C-A-S-T. And cos is negative, cos is positive in first quadrant all, and here, so it's negative in 2 and 3. So we're in quadrants. Draw the circles. Right here. And we're in the second quadrant, so there's the terminal arm. And we're in the third quadrant, there's the terminal arm. So the rotation of theta is this. This is in the second quadrant. Drop a perpendicular to the x-axis. And we're in the third quadrant, so this is the rotation for theta, right around here. And the reference angle, we drop a perpendicular to the x-axis. And cos is this, cos is the x, so the x is a negative a half in both quadrants. So that means hypotenuse is 1, and this side is root 3 over 2 positive, and this side is root 3 over 2, but it's negative because it's going down, positive going up. So opposite root 3 over 2, this is a 60-degree angle. That's your 30. So your reference angle is 60 for both of these quadrants. Opposite root 3 over 2, no matter if it's negative or not, it's still is 60. And opposite a half is 30, so the reference angle is 60. Second quadrant, theta is 180 minus the reference angle. So it's 180 minus the 60, so that's 120 degrees. And in the third quadrant, theta is 180 plus the reference angle. We practiced that in the previous video. Reference angle is 60, so it's a 240. And again, check your calculator. Cos 120 should give you a negative 0.5. The cos of 240 should give you a negative 0.5 if you're correct. And we have another one to do, but we can't do this one because it's not a special right triangle, so we have to use our calculator. So we have to use, and we can get my calculator here. Here we go. Turn on my calculator. And so I have, as you can see, the sine. So first of all, move the calculator away. I have to go and do the sine of the reference angle is a positive decimal. So if I make the decimal positive, as I have, then I'm finding the reference angle. So the reference angle is going to be sine to the negative 1 of decimal 432. So that means the reference angle comes out to be 48 degrees. So we'll just show you, I'll show you on the calculator now. So we have inverse sine of decimal 7432. And as you can see, 48 degrees. But we have to find out what quadrants to put it in. So we're going to add sugar to coffee. Sine is negative. Sine is positive in 1 and 2, so it's negative in 3 and 4. So we draw the circle. We draw it in. So we put it in quadrant 3, which is right there. And we put it in quadrant 4 after we draw the circle. There's quadrant 4. Perpendicular to the x-axis. Perpendicular to the x-axis. And again, in the third quadrant, theta is all the way around to here. So, what is the reference angle? The reference angle is 48, so that's a 48 degrees right there. And that's a 48 degrees right there. So in the third quadrant, the third quadrant is 180 plus the reference. It's 180 plus your reference angle. So it's 180. I said plus and I put a minus there. Plus the reference angle of 48. So that gives us 228 degrees. And in the fourth quadrant, the theta is all the way around right to here. So if this is theta, then we have theta is 360 degrees minus the reference angle, which is 360 degrees minus 48, which is 312 degrees. And check your calculator. The sine of 228 should be negative 0.7432. Sine of 128. Now let's just check. The sine of, did I say 228? Yep, 228. And I got negative 7431, approximately, not exactly, but it's pretty close. And if you do the sine of 312, you should get the same decimal close to it. And the last one, the sine is 2.61. Remember, or sorry, the cos is 2.61. Remember the cos and the sine, negative 1 less than or equal to cos theta is less than or equal to 1. Notice 2.61 is not here. So that means theta, there's no solution. You can't work this out because 2.61. And let's use the calculator. Let's use inverse cos of 2.61. Let's see what happens. Error. Because it doesn't exist. The most on the unit circle, the highest value is 1 and the smallest value is negative 1 and all in between. So that brings us, hopefully you understand how to pick up the values of sine and cos into different quadrants when you're given the measure of a half plus or minus, root 2 over 2 plus or minus, root 3 over 2 plus or minus, or if you got another decimal, use your calculator. And if you like my video, click the like button, subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my video, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.